All right. Well, hello, everyone. Welcome to our September Guild meeting. Today, we have a really great presentation for you from the Science Activation Team, NASA TREX. But before we jump into their opportunity for you, I want to do a little recap and a little intro. So, Emily, if you don't mind, I'm going to share my slides for a moment. Cool. So, in today's meeting, I really want to emphasize two things today, that the Astrobiology SciComm Guild is a community of practice. And I feel like we don't talk about this enough, what a community of practice really represents. Communities of practice generally have several things in common here that I tried to illustrate, particularly for the goals of the Guild. We're building a community around science communication opportunities for you, and we're finding ways to leverage, invent, and co-create those opportunities with you and for you. Usually in our meetings, we hear from NASA science activation teams who we've partnered with to bring you really exciting opportunities for you to evolve as science communicators and use your expertise, be subject matter experts for these SciAct teams. But I also want to emphasize that we're really here to co-create opportunities with you as well. That was one of the original visions of the Guild. So if anyone ever has any opportunities or ideas, or they want to brainstorm some opportunities for science communication with others, please let me know. Please don't hesitate to share that. And I actually want to dedicate some future meetings to this topic. So before we move on, I just want to hear from you all. Does anyone want to share any opportunities or thoughts, or give an intro of who you are? Because I love hearing from you all, and I don't get enough opportunities to hear who you are and what you all do. And we can also pause a little bit at the end and continue this. So I'm not hearing anyone jumping up, so I'm going to move on in this case. And I would like to, the other thing I wanted to accomplish in my little intro here is I want to go over a couple of, I want to recap the previous SciAct opportunities for those who may have missed them, because I want to remind you all that these opportunities are sort of ongoing. It's not like if we had a meeting 1 month and you heard from, some speakers, that was the end of that opportunity to work with them. These are open calls for you all to participate. So starting from our very first meeting of this year, from February, that was our sort of relaunching Guild 2.0 intro meeting. And we heard from a SciAct team called Earth to Sky. Earth to Sky partners with folks who do field-based earth science and planetary analog research, and they're really interested in place-based learnings. And so the way Guild members can help this team is if you do any analog field research, or if you just use NASA climate data in your research, they would love to work with you and hear from you, whether by just doing a webinar for their group, which meets monthly, or if you are ever doing any field research, you can invite them along and maybe do some education and outreach while you're doing your field work. So Genevieve Demessières and Chris White presented this. So if you want to reach out to them directly, feel free to do that. And I'm also happy to answer any questions and put you in touch with them if you're interested in that opportunity. Moving on, we then heard from the Culturally Inclusive Planetary Engagement Team. This is a SciAct team called REACH, and this is folks at based in LPI who are doing this group of culturally inclusive planetary engagement workshops, which are basically these 3-day workshops supporting conversations to engage Black and Latinx communities in planetary science. And participants not only learn the state of the art and how to do this, but also co-create and lead some engagement activities at the end of the workshops. And there's their website. They have the workshops running at various times of the year in different locations throughout the states and in Puerto Rico as well. And so they've had a couple in the summer from New Orleans to Mountain View, California. We just had one in Miami. And actually this week they're doing a workshop at the American Natural History Museum in New York. And their next workshop is coming up in November in Puerto Rico. So if you're interested, they do offer stipends for those who participate. There's the code for their website if you want to learn more and register for the November workshop. And again, please reach out to me if you have any questions on any of these opportunities. In our March meeting, we heard from the Infiniscope SciAct team led by Ariel Anbar and Joe Tamer, and they basically create these interactive web portals to support your lessons in various planetary science topics. If any of you do any teaching, if you want to be a subject matter expert and consult on the lessons they're developing, or if you have any ideas on lessons that you may want to develop, you can be a subject matter expert and work with the Infiniscope team. Civil servants, researchers, even graduate students are eligible to apply. All of you are considered subject matter experts. If you have any ideas for lessons, they're very interested in hearing from you. I've got a list here of topics, adaptive lessons that they've already developed that you can adopt or work with them and learn how to use their adaptive lessons or develop others. So please let me know if you're interested in this opportunity from the Infiniscope team. Moving on, and I will make these slides available. I apologize, I'm moving quickly because I want to make sure that we have enough time for our speakers today, but I will make these slides available to you. Then we heard from the Open Space team in our June meeting, and we heard from Megan Villa and Dr. Rachel Smith on how to use Open Space, which is an interactive data visualization software using data sets from stellar, exoplanetary, planetary science data sets for your outreach presentations and activities. And then we heard from the NASA Scope team. I believe this was also this summer. We heard from Jessica Swan with the NASA Scope team. And this is a team dedicated, this is a sort of a unique SciAct team. They're dedicated to connecting subject matter experts like you all with SciAct teams in a funded opportunity. They have these seed grants that they offer several times a year where you can propose to work with a science activation team to do some science communication. So unfortunately, the last round of applications for this seed grant opportunity just closed. We just missed it on the 15th. However, they in this opportunity, they were offering grants to travel to the AGU meeting to do some networking and communication training. And if you do any work related to NASA SMD, basically, you're eligible to apply for this. And the next round of applications will be announced very soon, I believe early next year. And if you are in some NASA affiliated, if you work in a NASA affiliated research program, you're eligible to apply. And again, their next application cycle will start in January. And so there's the code if you'd like more information on NASA Scope's seed grant opportunity. And that's a recap of everything we've done so far. So again, if you have any questions or feedback or ideas on any of these or other topics that we've offered, please get in touch with me. And I will now, or actually, let me pause and make sure that nobody has any questions before we hand it over to our next speakers. Does anyone have any questions or thoughts?
Can I go ahead and share my screen?
Yes, please. And I will exit this. And okay, I'm going to hand it over now to the NASA track. Am I still? Oh, I'm still sharing. I apologize. Thanks, Emily. Okay.
So can everybody see my screen?
Yes. And please introduce yourselves if you don't mind, Emily and Brian.
Hi, everybody. Good morning here from Southern California. And thank you so much for this opportunity for us to be here to talk about the solar system tracks. My name is Emily Law. I am from Jet Propulsion Laboratory. My role there is basically in managing a number of different data science and technology projects that related to both planetary and Earth science. But my favorite project is really the solar system tracks, which we will go give you a overview. So this is a tech team presentation. I'll start with doing some demos and talk about this, and then we'll go into let Brian talk about stories. Anyway, so Brian, all yours.
Sure. Thank you very much. My name is Brian Day, and I am the staff scientist at NASA's Solar System Exploration Research Virtual Institute, way too long a name, headquartered at NASA Ames Research Center. And again, my favorite project is working with Emily and the team at JPL on NASA Solar System Treks, which is an infrastructure project within SciAct. So we're a little different than a lot of the other teams that you may have worked with, but we can provide some really neat value. And Emily's going to start out and show you the interface and introduce you to NASA Solar System Treks.
Okay, thank you, Brian. So this is a program that provides a set of what we call interactive visualization and analysis tools, what we call portals, for a growing number of planetary bodies. So in order to utilize the portals, the one way to do is just go to our home site right here. I highlighted up there is https track.nasa.gov. This is, the homepage. When you get there, you will see that there's a number of tabs on the top here, but on the bottom here, if you click on that Explore, you will see that the available portals that we have for a number of planets, moons, as well as asteroids. So I believe that Brian is going to touch on most of that. So we can just talk about in addition to homepage, we have a galleries, and under there we have feature of the month. Each we produce a image and also a story about the image for each of the months. So there's a number of those, so you can go through them. And we also have a set of videos. So if you scroll down, you will see that there's a number of videos that make basically using the portals to tell science story. So this is something that a number of scientists that created, and we hosted here. So if you're interested in using the portals to create this kind of videos, we will be happy to host them as well. We also have a set of virtual reality library. And here, for example, if you go to Mars, and you can pick any of this preset that, virtual reality experience, you click on it, and there is a QR code. So what happens is that if you use your mobile phone, scanning this QR code along with a very inexpensive pair of Google Cardboard goggles, and you'll be able to experience the flyover of that path immersively. In addition, since we have a number of data sets available on each of the portal, here is some of the introduction sets to show you some of those features that you might be interested in. So in addition to the galleries, we have features which give you some more information about some of our tools. And then we have links to other resources that could be useful and available to you. So let's go back to home, and we'll use this opportunity to give you a quick demo of some of our basic tools. So let's start with Mars. So here you can click on Mars and say Explore, and it will take you to Mars Track. The other way to access Mars Track is you can just simply go to track.nasa.gov/Mars, and it will take you there. Simply for all the planetary bodies that we have, the portals that we have, you can do the same thing. For example, track.nasa.gov/moon will take you to the moon track. So initially, when it comes up with the portal, it will give you this pop-up windows. I would really encourage you to, at the very first time visiting the portal, do this tutorial. We are not going to do it right now. We'll just skip it. What the tutorial does is basically walk you through the menus that we have, upper corners, right-hand corner, left-hand corner, and lower corners as well. So guide you step by step, what are the menu functions that we have. So for now, we'll just skip the tutorial. And we'll start with maybe some of the data layers to show. So Brian, maybe you can, so here is upper left-hand corner is the data menu. If you click on it, there's a search capability. And we have different type of searching capability. We can base on metadata, a faceted search on type of mission of instrument, or spatial search in terms of, a polygon and search by point, or also based on different type of category of products as well. Without the search capability, you can scroll down here. You can see that there is a number of data products that we have. We'll start, at the top is really some of our bookmarks, which are basically guided tours. So Brian, would you recommend some of the data for us to start looking at?
Sure. Let's do a search on MOLA, M-O-L-A. And there, the MGS, MOLA, Mars Express, HRSC color hillshade blend. So instead of the visual view, now we're going to look at essentially a laser altimetry view as well as stereo camera, giving us a view of altimetry.
So when you click on it, it'll give you the abstract, the description of the data sets, and then you can download or you can add to a list of downloads you want to do later. You can fly to there. Let's just go ahead and add that. And you will see that on the map window, it will show up there. Let's close this. Okay. Is there other layers you want to talk about this layer, or you want to go ahead and?
So again, here we have a color-coded view of altimetry. So blue is low, the white is high. You can see this actually brings a lot of topography into sharp relief. So it allows us to visualize a lot of topographic details that can actually be hidden in the very dusty view of just a plain visual light camera view like we start with. And yes, there is a legend available. So if you go back to the data, we do have, yeah. There you go. So color coding shows you the different heights. But there are other ways to determine heights. So, this is great. You have one visualization here, but our tools also allow you to get very precise views of altimetry, and Emily will be demonstrating that.
And also you can log in. Go ahead, sorry.
I was just thanking Brad for his question, though.
So is there a question we should answer? No? Okay.
No, we did. That's what we were doing.
So the other thing is, this is a basic, a GIS system. So we have all the basic GIS functions such as zoom and pan. You can use this button here as well. I'm actually using a mouse, so it can go a lot faster, zooming in the area as well as we zoom in and out. So in order, just like what Brian has talked about, we have tools to make measurements. So what we're looking at here is, one thing maybe we can introduce is there's the base map capability down in the bottom lower right-hand corner there. We have the ability to enable nomenclature as well as reticle. So those you can adjust on your own. See. And then we have the ability to quickly fly to any area of your interest. For example, if we want to zoom into, let's Marianas, it'll just zoom you right in there. And then you can zoom out. And so you know that Marianas is really a huge canyon, much bigger than the Grand Canyon we have on Earth. In order to measure it, so you can go up to this menu on the upper right-hand corner there, and you can try to calculate the distance. For example, let's do the freehand. So you can start from the end here. Oops, so I think I get it too soon. Click here. Sorry. Let's do it again. And it can show you that is almost 5,300 kilometers long, way bigger than the Grand Canyons that we have on Earth. In addition to just looking at the distance, we can also calculate elevation profile. Again, we can just do it from here as well. And you can use the tools from the tool menu, or since we have already drawn a line, we should be able to just do elevation here. And you can see that, the depth and the height of the valley at different points and as well. Okay, so this is the elevation profile. We do the marker. And we also have the available, the tool available to calculate sun angle, and as well as generate 3D print files. What 3D print file does is in any area on the surface of the Mars, since we are on Mars track, you will be able to draw a rectangle, and then it will allow you to be able to generate either an STL or OBJ file that would download to your computer, and then you can send that 3D print file to any 3D printers, and it will actually give you a physical models of that area. And then here is also our Experience Track VR, as I mentioned earlier, allow you the ability to be able to draw a path anywhere, again, on the surface of the Mars. Oops, click. And it will give you a QR code. You use your mobile phone, capture this screens, and it will download the data sets as a stereo pair of data sets into your phones. Without the Google Cardboard compatible goggles, you can still see the stereo on your phone. But with the goggle, then you'll be actually able to do a immersive 5-over. Okay. So those are the basic tools. We also allow you to share links. If you look at some data sets and you are happy with it and you would like to share with other people, you can click on this. It has the ability to you can cut and paste and then send the link to your friends or your colleagues, and they will be able to pull up the same data sets that you were looking at, or multiple data sets that you already pulled up, added to the map. Or you can also do and embed the images into an iframe for your web portal as well. So we also can do screen capture. So let's now look at the different projection. So in addition to this is the 2D global view projection. If you come down to the lower left-hand corner here, you click on projection. We also have this is the global map right now that we were looking at. We also have the North Pole map, as well as the South Pole projection. But the most interesting thing is that we have a 3D globe projection as well, that you can zoom in and out, you can spin it around. In addition to that, if you toggle this button on the top here, will allow you to use the game control keys, which is, if you're a gamer, you know that the ASD WQE key, that you would be able to actually do a 5-over. So let me just zoom in here. So this is this ability for you to be able to fly over to the area that you like. So this is just really fun things to do. And this is how majority of the video I showed you earlier to tell science story is how we utilize this portal to be able to create those video. Okay, is there any questions or anything else, Brian, that we should do a demo on?
While you're in 3D mode, why don't you demonstrate the country mover?
Okay, we do have a country move over capability in 3D mode. So what it does is allow you to be able to select either US states or any country. For example, let's just do Afghanistan, right in the top there. And what it does is actually, yeah, do I close this? Hold on. Oops.
It takes a look. Yeah, you have to leave that open.
I have to leave that open. Sorry. 3D. Let's try again. Let's try United States. Let's pick on the top, Alabama. So what it does, can I do this?
Yep.
No, I can't close it, huh?
No, you cannot. So select the state, and then you can zoom out and you can drag the state over any terrain that you want.
No.
So we have a nice volcano down there in the Tharsis area to the lower left. So we can compare those volcanoes to Alabama there.
I think I have this turn on, that's why. Okay, now you should be able to drag that to just do some comparison of the size of the shape. But basically, we just displaying the footprint of that state right now onto the features that where you want it. At the beginning, it basically put it on where it relative to the Earth, where it should be, and it scaled to the Mars at this point. So it also allowed, there's a color ramp here that allow you to be able to change the color as well. Okay, so that's the tools. All right.
You see that Emily there has the power to change Alabama from a red state to a blue state. Imagine that.
All right. So is there anything else we should demo?
I think that's a good start. What I'd like to do is show everybody some examples of how this tool and the many different data products that we have integrated in here can be used to facilitate visualizations that can help you actually tell your stories. So let's go ahead and hit the next slide. We'll start out with Mars. So here's a view of Mars from the Viking orbiter cameras. This is how Mars would look if you were looking out the window of a spacecraft in orbit, a completely dry desert world, no liquid water anywhere to be found. Next slide, please. So here we've changed to that laser altimetry view. And again, one of the things this allows us to see is that Mars was once a world where liquid water flowed across its surface. We can see many dry channels, places where great channels of water flowed into what appears to be a bay that then opened up into a great northern ocean on Mars. Mars was once wet. Let's zoom in again. And here we can see very clearly how the flow of water carved and streamlined terrain on the surface of Mars. This is about 3.5 billion years ago. Okay, next slide. We can get further insights into the wet past of Mars by looking along the shoreline of what appears to have been a great ocean. And if we look inland from that shoreline, we see some fascinating clues. We see scars of ancient mega tsunamis that rushed many, many kilometers inland. So let's go ahead, next slide. We can see this classic thumb-printed terrain that shows where the landscape was really deeply scarred by the turbulent flow of massive amounts of water flowing inland. Next slide, please. And we can see the outflow channels where once the water had rushed inland, it then flowed back toward the ocean basin and left these dramatic outflow channels. And then here we've gone to Jezero crater. And this is, of course, an area of great interest right now. And looking at Jezero, we can see inflow channels coming in on the west and the north. And we can see an outflow channel on the east, indicating that Jezero was once a great crater lake. Next, please. Zooming in to the breach in the wall on the western side of Jezero, we can see the inflow channel and see where it flowed into the crater. And as the water slowed, it left a delta deposit, a great, beautiful delta deposit on the floor of Jezero crater. Here we're looking at the outflow or the inflow channel to the west and seeing how this channel actually flowed across the highlands of Syrtis Major, gathering material from a vast watershed. And that ended up flowing towards Jezero crater, gathering and concentrating that material. Next, please. We can look down detail into this massive, this was actually a huge river, and it may have brought material into Jezero crater over a period of millions of years. Continuing to zoom down, we can look at details of this wonderful inflow channel. And whoops, back up one, please. Back up one. There we go. So here we are now looking at the breach. We've positioned ourselves so that we're looking ourselves at the breach in the wall of Jezero crater, seeing where the river actually flowed in. So we're looking inward toward the crater. Next, please. And now we've positioned ourselves within the crater, again, looking at that inflow breach. And you can imagine this massive amounts of water cascading into Jezero crater and its Great Lake. And now we're focusing on the sedimentary deposits of the Western Delta deposit. This is where Perseverance is currently playing. Zoom in, please. Next slide. And so we can look at a great deal of detail here. And again, you can position yourself anywhere you want, create any vantage you want. Next, please. And again, looking at the wonderful layered sedimentary deposits that Perseverance is now exploring. Okay, so now we are at Valles Marineris. We're looking at the Coprates Cosma area, and we'll zoom down. And here we're looking over the Montes Coprates at the sedimentary Paleo Lake deposits, as well as landslide deposits on the floor of Jezero crater, of Valles Marineris. Next slide, please.
Really, Brian, this is one of the the site that identified at the Human Landing Site Workshop, Human Exploration Landing Site Workshop.
That's right. So this, as well as Jezero, were both identified, and we do have actually a layer showing the initial potential human landing sites that were identified in that workshop. So here we're looking at the 8,000 meter tall north wall of Valles Marineris. Very spectacular. As we zoom in, we can see the fascinating gullies that appear coming out of certain layers within the wall. Now Emily's advanced to showing us, again, view of the spectacular Martian volcanoes. They are quite large. Next slide, please. There we go. Now we're looking at a laser altimetry view at the detail of Olympus Mons, a truly immense volcano, and you can see the various landslide lobes extending out to the northwest. And we can zoom down. We can actually interactively fly down into the caldera of this giant shield volcano. To give you an idea of scale, you could easily fit the entire island of Oahu inside this caldera. And here we're using the country mover tool, and I've showed Maryland, the state of Maryland, compared to the edifice of Olympus Mons. But the volcanoes that we see on Mars, while most of them are billions to millions years old, volcanic activity is not relegated to the distant past. Here we're seeing an area, the Ceres fossae mantling unit, that is an example of recent volcanic activity, estimated to be somewhere in the 46,000 to 122,000 year range. So that's very recent. Let's stay there, please. Back up. So one of the things that we're seeing here is that this is different than a lot of the volcanic features we see elsewhere. We don't just have lava flows coming out. This is a pyroclastic ash deposit. And some hints about the nature of this very interesting volcanic activity come from the young crater Zunil, only about 10 kilometers to the southeast. And Zunil is an example of what we call a rampart crater. It's surrounded by a thick deposit, ejecta blanket that is indicative of an impact that happened in terrain that had a subsurface rich in water or ice. And so that gives us a clue that the explosive activity associated with Ceres fossae may have been a result of magma rising up through the crust and encountering a layer of water or ice, and resulting in a phreatomagmatic steam explosion, blasting ash into the surrounding landscape. That interaction between magma and water is, of course, something of great interest from an astrobiological standpoint. Okay, next slide, please. Also in the volcanic areas, we see skylights, pits. These are actually areas where ceilings have collapsed over subterranean lava tubes. Continue, please. So we can zoom down and see a number of these fascinating skylights. And again, these subterranean lava tubes, next please, are wonderful examples of areas that we would love to explore, especially with astrobiology in mind. Next, please. The realm of water is not limited to ice at the poles or ancient river systems. We have today clusters of bands of mid-latitude glaciers at 40 degrees north and south. Next, please. So we can see examples of debris-covered valley glaciers such as this. We can zoom down, fly along, and see. If you've ever been up to Alaska, this will look very familiar to you. You're seeing medial moraines, you're seeing flow features. This is all at a latitude comparable to Washington, D.C. Next, please. Here we see an example, that toe-like projection of a Piedmont glacier. Let's zoom down and take a closer look so we can see this ice flowing out between the mountains above it, and this beautiful toe of dust-covered ice. Next, please. Very common form of glacial landform on Mars are the lobate debris aprons that we see oftentimes arrayed around mountain peaks. Here you can see glacial ridges and even a Bergschrund crevasse where the head wall of the glacier meets the mountainside. Next, please. Craters can also be very good places for glaciers to form. Here we see a concentric ring glacier within craters. Brad, your question was, are these active glaciers? In terms of flow, we're not sure if they're still actively flowing. We haven't been able to look at them very long, probably not. But from Sherrod, we have been able to see that these are not just fossil glaciers. These are not just the rocky remains left behind as the ice melted. We can actually see that in many cases, we have a few meters of rock on top of perhaps up to hundreds of meters of ice. So these are still glaciers in many, many cases. Potential great resources. Here's a fun example. So we see another example of one of these rampart craters where an impact happened and it created this muddy sploosh around it. And you can see the classic example of the rampart crater muddy ejecta blanket around it. But then look above it, and you can see examples of where there was actually flow of liquid extending out. So you can imagine water flowing out from the rampart. And then after all that, excuse me, back again, back of that, we can also see where a lobate debris apron glacier has actually overridden the rampart. So we can see a lot of neat stories are being told to us here. Okay, next, please. We're not limited to Mars, so we can then head out to Jupiter's icy moon Europa, and we can see its very young surface. It's clearly not degraded by impact craters. We have a very fresh, geologically fresh surface here. Next, please. And the networks of ridges and areas of chaotic terrain are very much indicative of and give us clues to the ocean of liquid water that lies beneath the crust of Europa. Okay, next, please. So here we are also in the Jupiter system. We've just added a new portal, Ganymede. And here again, we can see a relatively pristine, not as pristine as Europa, but still a relatively pristine surface. And next, please. And again, we can see these really interesting ridge-like formations. And we do realize now that Ganymede is also a water world beneath this global ice cap. Next, please. Continuing out to Saturn, we go to its largest moon, Titan, covered with its dense atmosphere, even denser than the Earth's, but we can penetrate through that atmosphere. Next, please. And we can look down into its seas. In this case, this is Kraken Mara, and the seas of Titan are actually seas of liquid hydrocarbons, and some of them even have these wonderful chains of exotic islands in them. Next, please. Also in the system of Saturn, we have a portal for Enceladus. And Enceladus is, of course, a moon of great astrobiological interest. Next, please. Especially in the region of the Tiger Stripe fossae, these rifts that are the sources of actual geysers of water erupting out into space. Next, please.
I just would like to add that in addition to Enceladus, I think we have altogether 7 icy moons portal. So this, for example, Mimas, I forgot what the other ones are.
Tethys, Dione, Rhea, yeah.
So those
Phoebe,
are 4 as well.
So here we've gone out to Ceres, the dwarf planet Ceres, and wasn't really a place that we were initially expecting to be of great astrobiological interest. But as we zoom in next, please, to Okator Crater, we see these wonderful deposits of salt that are indicative of a mantle in Ceres of icy, slushy salt water. And we see on Ceres examples of water-based cryovolcanism. These are deposits left behind by such activity. We can see another dramatic example. Next slide, please. In the cryovolcano Ahuna Mons. This is the tallest, most pristine example of a cryovolcano on Ceres. So again, instead of hot silicate magma volcanism like we have here on Earth, they have ice volcanism going on Ceres, water ice. And over time, we see these volcanoes slump and deform plastically, viscously, and go from being mountains to pancakes. And there you can see just the hint of a relic cryovolcano within the crater Begbelel. Next, please. Other hints of the activity going on in the presumably aqueous mantle of Ceres are seen here in the Samhain Catani, where we apparently have a plume of material rising up in that mantle, interacting with the crust, spreading out, and causing extensional fractures in the crust here. So beautiful example of really hints of what's going on beneath the surface. Here we have the asteroid Vesta. Looks like part of it is missing. The southern part seems to have been cut away, and as we look in the next view, we see that is in fact the case. We have two massive impact structures where Vesta was almost destroyed by asteroidal impacts in the distant past. And we can see more evidence of that in concentric fractures, circumferential around the minor planet and concentric around those impact basins. And this tells a fascinating story because we see debris from Vesta spreading out across the solar system and even as far as here on Earth, landing in the form of the Howardite, Eucrite, and Diogenite meteorites. And this speaks to the interchange, the exchange of rocks between worlds. And again, from a standpoint of astrobiology and the whole idea of panspermia, this is interesting. Next, please. Here's another asteroid. This is Bennu. We're very much looking forward to very, very soon having our sample return from OSIRIS-REx coming from Bennu. Next slide, please. Here we see the actual sampling site, the Nightingale site. And we believe that the material that is going to be returned is basically very similar to what we see in carbonaceous chondrites, which can be very, very rich in organic material. But also looking across the surface of Bennu, we see rocks that are different, that stand out. These are exogenous basaltic boulders. Their spectra do not resemble anything else seen on Bennu, but they do match Vesta. These appear to be, again, fragments of Vesta that got blasted to Bennu. Now, that leads us to another interesting feature within the solar system treks that Emily touched upon, is the ability to do tours, guided tours. So it isn't just free format exploration, that's very valuable, but also we can give guided tours over selected terrain. So here you see for Bennu, we have candidate landing sites, guided tour of the first named landforms on Bennu, as well as a guided tour of places on Bennu where we find fragments of Vesta lying on the ground. As Emily mentioned, we have the galleries area with Feature of the Month article, also the narrated videos and virtual reality libraries. So next slide, please. She mentioned the videos. Next slide, please. So our asks of you. We would hope that you would use our portals to help tell your stories as well as to conduct your research. We hope that you'll give us feedback and ideas on how we can improve and expand the Solar System Trek portals. And we would hope that you would partner with us in creating content, such as guided tours and narrated movies. We can work with you to create content in various venues that you may work with, and we would love to work with you in content that can be added to NASA's Solar System Treks. So we hope that you'll enjoy using our portals to good advantage. Thank you.
So in addition to hosting your contents, we have the ability to host your data as well. If you are doing some research and end up having some data set that you want to make it available to the community, we will be happy to host those data, as well as tools. If you actually develop some tools, analytics tools, or tools that would be beneficial to the community, we're happy to make them available, help them, providing a platform to distribute your capability for use by the community as well.
Okay, thank you so much, Brian and Emily. That was great. I sure wish I knew of this when I was doing some presentations back in my graduate days. I would have loved to use some of these illustrations. Okay, so thank you so much. Does anyone, I know, Brad, I know you had a question. Did you want to go ahead and ask, or if anyone else has any questions?
Oh, certainly. I'll jump in. While others think of questions, first, I mean, this is amazing. I didn't know this existed out here, and my mind is just blown from the scope of this. And I'm definitely going to share it and use it. My questions was with the videos. You say to partner with you in creating content for not only the guided tours and narrated movies. Who do we contact for that? And do you have people that would work directly with us for like making videos like Mike here or somebody else at JPL or Ames?
Absolutely. So in terms of contacts, take advantage of Emily and me. We'd be happy to work with you. Most of the videos so far have been things that I have produced. So those are basically just getting into the interactive mode that Emily demonstrated and doing screen captures as I fly across the surface of whatever world we're interested in. But I would be.
Are those videos narrated too by you when you do it? Okay.
And so we narrate those. But, I mean, quite frankly, I am not an astrobiologist by training. And so it would be wonderful to have some videos that are very specifically astrobiologically themed. And so we would love to work with you on that. So if you've got specific areas that you want to highlight, specific features, and then, I'll be happy to work with you, happy to help you capture flyovers of whatever terrain you want. We can look at different data products that might showcase the features that you most want to highlight. And then, we can work with you in producing the video that we can then post on Solar System Treks, or you can post anywhere else you might want.
Okay. Is email the best for that, or is there a Slack space that we can engage you with? I don't know if you're on the Guild space or if you have your own Slack
if you're gonna contact me, I'd highly recommend email.
Okay.
Slack, yeah. So brian.h.day@nasa.gov.
Thank you.
And any generic request, you can send it to just trek.jpl.nasa.gov. Just email it to trek.jpl.nasa.gov.
Is it trek dot or trek at JPL?
Oh, trek at, sorry. Yep.
Trek at jpl.nasa.gov, yeah.
Okay. And I think another takeaway from this talk, as well as some others we've seen, is that these are such great tools, not only for engaging learners, but really engaging your colleagues. These are excellent for research presentations as well. And I think that's something that we emphasize in the Science Communication Guild is often, spreading our science to the public, but let's not forget that these are excellent for spreading our science to, at conferences to our peers and colleagues as well. So boy, we got to think about ways of really getting the word out on this Trex tool. I will do that.
Very good.
Okay. Well, thank you all so much for yet another Guild meeting. It was great to see you all here, and join us next month in October. Thanks, everyone. Have a good rest of your Monday.